Hey guys, yes, it's me, and yes, I'm sitting at the teacher table, but I wanted to walk you through your notes real quick. That way you kind of had a better understanding of what they are talking about. So, you should have glued in this nice page on from the folder onto your notebook. I have mine glued into page 32, so that's the page that I hope you're on. If you're not on that page, it's okay. Let's just get as close to it as we can. We're going to be talking about input-output tables today. Input-output tables are sometimes called function tables or pattern tables. And that is because when you see the table, you're going to find a pattern. Remember, a pattern is something that repeats itself. So like if you count by twos, 2, 4, 6, 8, you're following a pattern. If you look at shapes, you have the pattern red, blue, red, blue, red, blue. It's just a repetition. A lot of times, though, you'll hear it as input-output tables. Every time you have an input-output table, there is a rule, okay? And the rule has to be the same all the way down. You can't have the first part of the table be times 2 and the second part of the table be times 4. The rule has to apply always to all of them. It helps you understand the relationships between two columns or two rows. If you know the rule, it's easy to complete an input-output table. If you have a complete input-output table, you can determine what the rule is. If you look at this first one, the rule on this table is the number of kids times 2, because every time you go from left to right on this one, you will see that 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So all of the rules are the same. All of the rules are the same. Okay, so your rule is times 2. If you look at the second one, it's kind of, when I see this, I think 4 doesn't get to 11 very easily. Like this one where 1 got to 2, 2 got to 4, 3 got to 6. That looks like it got there easily. This one doesn't look as easy. If it doesn't look like it gets there as easy, it's not usually multiplication. But if it's still increasing, so the number over here is smaller and it's becoming bigger, your only options are to either add or multiply. So in this situation, they're adding 7 each time. And so when you see that, and you can double check it by counting, and they're adding 7, all that does is show you that the rule is plus 7. Now you may see these letters down here, okay? See these? Those are saying where it started. So it started in the X table. It added 7 and came out the Y table. I like to think of it as a machine. It goes in one side, something happens, and it comes out another side. Now, in this situation, if you look at this input-output table, the bigger numbers are on this side, and they're becoming smaller. If you start with larger numbers, then you are either having to subtract or divide. Those are your only options. Now, I know my 5 facts, and so right off the top of my head, I see that this is 25 divided by 5 is 5, and 35 divided by 5 is 7. Now, I can do in my head, I know that 12 times 5 is 60, so that means 13 times 5 is 65. So if I work backwards, I'm dividing by 5. And if I continue to do this, I know that all of these match, and therefore my rule is divide by 5. Okay? Now, divisions for some of y'all may be a little hard, but if you think of it the opposite way, if you know that 5 times 5 is 25, then you know that it's a fact family and it goes the opposite direction using division. Now, these 3 tables you have seen and are familiar with. This is not the first year you've seen these type of tables. But on this last table, it's a little bit different. When you see an input-output table going sideways like this, you can't go from 4 to 6 to 9 to 13. That's not how it works, okay? So what you have to do is you have to go from top to bottom. Top to bottom. And figure out, how did 4 become 10? How did 6 become 14? How did 9 become 20? How did 13 become 28? Okay? Now, this one's a little tricky because if you do it, then you see you've got plus 6, plus 8, plus 11, plus 15. So this one isn't really a true input-output table, okay? This one's a little bit trickier. You'll see more of these in 5th grade. But this I wouldn't count as a good answer because you have to have something that has all of these the same. So I would put a big X out to the side of this. Say, no way. This would not be a true input-output table because these are not all the same. Now, underneath your input-output table, I want you to draw one, like this horizontal one, and create a rule. So you draw the box. Okay. And then you draw a line and we label it. We'll just use X and Y. And now I want you to create an input-output table where it goes from top to bottom using whatever rule you choose. Okay? And I want you to write the rule out to the side. I'm going to be checking these because I want to see that you understand how to do it. And then once you get it done, and I see that you understand, then we'll move on.